So test is on Thursday of this week. All purple worksheets, formative corrections, which you got back today in class. Huff and Gasper, the blue extra credit, all that's due Thursday's test. It's more of a quest, not a test. A little bit longer than a quiz, a lot shorter than a test. All good things. Okay. So the warm up for today is how many radians will the hour hand of an analog clock rotate in 48 hours? More time? Okay. So first off, this is the hour hand. I don't know if you guys know that. That's the hour hand. It points to the hour. Okay. So right now it's saying that it's 10 to 2. Okay. So how many laps does that hour hand do in 48 hours? 48? Do you agree with 48? The minute hand would do 48 laps. Yep. But the hour hand only does 4 laps. Okay? Because it goes around every 12 hours. Okay? It makes 1 lap every 12 hours. So it's doing 4 laps. Or even better, let's get it mathematical. It's doing 4 revolutions. Okay. Which means then we want to know how many radians 1 revolution, almost said 1 radian there. 1 revolution is 2 pi radians. So that hour hand would do how many radians in 48 hours? 8 pi radians. Okay. Good time. Convert both of those, please. Okay, so on the first one, it's going to be 135 degrees, right? Plus 47 over 60, because that's the minutes part, plus 23 over 3600. Agree? Okay. And I get 135 point, we'll round, I should have told you round to 3. 790. Really, I get 78972222. Yeah. Okay. Now, we're going to show you how the calculator can do that for you too. Okay. So, if you have a graphing style calculator, okay, you can add, just go to any old calculator page, and then we would have 135 degrees, 47 minutes. I'm getting the degrees and the minutes from this pi key down here, and 23 seconds. Okay. And then the calculator's got this little booklet thing right here. And what it does is it's got all these different things that you can do. And so if I type in just D, that'll get me down to the D's. And then I want to go to, come on now, this one. Okay? DD stands for decimal degrees. And then when I hit enter, whoa, oh, it went exact for me. There's my 135.79. on the other, $78.435. So then now we would take the 0.435, we would multiply it by 60. Apparently it smells like bug spray out in the hallway. And we get 26.1. Then we take that 0.1 and we multiply that by 60. And we get 6. So this one should be 78 degrees, 26 minutes, 6 seconds. On the calculator, we can go 78.435 degrees, and then we can go back into that book and scroll down to DMS. Yes. And there's my 78 degrees, 26 minutes, 6 seconds. Okay. So either way, give you a little shortcut, speed things up a little bit. All right. So that's our chain drive. I want to know the linear speed of the chain if the larger sprocket is rotated 4 times in 10 seconds. And then I'm also going to give you the other one, the next example too. I want the linear speed of the chain if the smaller sprocket is rotated 4 times in 10 seconds. Okay? So linear speed of the chain if the larger one is rotated 4 times in 10 seconds. Linear speed of the smaller one if it is rotated 4 times in 10 seconds. Okay? Go. It is making 4, oops, wrong color. It is making 4 revolutions every 10 seconds, right? Okay? And 1 revolution is 2 pi radians, correct? Okay. And 1 radian is 4.85 inches. Yes? Okay. So on top, we would have 4 times 2 pi times 4.85, and on the bottom we would have 10. So we're going to cross out radians, inches per second. So 4 times 2 pi times 4.85 divided by 10 is, I get 12.189 inches per second. It's moving about a foot a second. Agree? That's good. That's good. Okay. Now, the little one is moving at 4 revolutions per 10 seconds. So again, 1 revolution is 2 pi radians. but now 1 radian is, what did I say, 1.54 inches. So now I get that it is moving at approximately 3.870 inches per second. Hmm? Good time. All right. So again, to refresh memory, and I'm going to give you now the rest of the time. Okay. So you got plenty of time to work on SIF. Test is on Thursday. Purple packet due on Thursday. Green formative corrections due on Thursday. Puff and gas for blue extra credit due on Thursday. Okay? All that stuff due Thursday. What's up? More trig stuff. Starting the next unit.